right, second half of Appendix B1, picking up on page A18, fitting a line to the data that we have. It says many real-life situations involve finding relationships between two variables, like the year and the number of people in the labor force. In a typical situation, the data is collected and written as a set of ordered pairs, and then the graph of that set is called a scatter plot. So if I had example number 5, and it says the data in this table shows the number of people, P in millions, in the United States who were part of the labor force from 1987 to 1997, in the table, so that I don't have to write 1987, 1988, 1989, they're letting T equal 7. They're just taking that last number kind of thing. And so T equals 7 will correspond to 1987. So it says sketch a scatter plot of that data. So we could go through, and if I were graphing this, the first thing I would need to figure out is what's going to be my X values and what's going to be my Y values. Because I don't have X and Y, I have T and P. So we've talked about before that the independent variable is going to go on the horizontal axis and the dependent variable is going to go on the vertical axis. So I have to think about, does the number of people in the labor force depend on what year it is, or does what year it is depend on the number of people in the labor force? Well, I don't get to be a time traveler. I don't get to set the calendar. So the population of the labor force is going to depend on what year it is. So on my x-axis, I'm going to put that independent variable. I'm going to put the time, and it goes in the table from 7 to 17. So I'm going to, for my x values, I'm going to count by ones starting at 7 and go down to 17. Now, so that I don't have to go through and say 0, 1, 2, 3, 4, 5, 6, 7, and put each of those values in, remember that I can put this little symbol in, and that lets me skip from the 0 to the 7. And then I'm not going to indicate any other scale because I'm just counting by ones. If I was counting by something else, I'd have to indicate that scale. Then for my Y values, notice that they go from 120 to 136. So if I count by ones there, I'm going to have like 16 lines. So I think I'll count by twos there. So if I'm going to count by twos, I will need to indicate that scale, that at least I'm given these first couple of values here showing I'm counting by twos. And also, because I skipped from the origin to 120, I don't want to have to put every interval of 2 all the way there. Then again, I've put in that little symbol that just shows that I've skipped those values. So if I went through and I plotted those points, like 7, 120, 8, 122, 9, 124, 10, 126, and so on. If I went through and I plotted those points, this is what I would get. It's called a scatter plot because it literally just looks like points that I plotted that are kind of scattered everywhere, right? So that's where it gets its name, scatter plot. If I look at this and I try to figure out what type of a graph this might be, it looks very much like it might be linear. No, it's not going to make a perfect line. This is real world data. Real world information is seldom going to fit into a nice perfect little package, right? So there are going to be some years it's above average and some years it's below average and some years it's right on the average. But I could go through and just kind of hand draw in here something that fits the information that I was given, and yeah, it absolutely looks linear. So they asked me to sketch the scatter plot for example number 5, and then for example 6 it says find a linear model that relates the year with the number of people in the United States labor force. So on the bottom of page A18 it says a mathematical equation that approximates the relationship between T and P is called a mathematical model. So that's what they want me to find. They want me to find an equation that would approximate this. It's not going to be perfect. It's not going to land on every one, but it gives me an approximation. And it says when developing a mathematical model to describe a set of data, you're going to strive for 2 often conflicting goals, accuracy and simplicity. So for my information, it's obvious it's linear. To create the equation of a line, I only need 2 points. So for simplicity, I could just use 2 points. But that's not going to be very accurate. Because the problem is, I'm going to go through, and the 2 points that I'm going to choose are the 2 extremes. I'm going to choose the first point they gave me, 7, 120, and the last point they gave me, 17, 136. So if either one of those just happened to be a really high year or a really low year, it's going to skew all the data. I'm also basically telling these people they wasted their time and money collecting information all the rest of those years because I'm just ignoring that. But in order for me to be more accurate than what I'm being here, I'd have to go through and like find the slope between 7 and 8, and find the slope between 7 and 9, and between 7 and 10, and 7 and 11, and 12 and 13 and 14. I'd have to find all those. Then I'd go back and I'd find the slopes between 8 and 9, 8 and 10, 8 and 11, all of those. And then the ones between 9 and 10, 9 and all of those. We could sit here and do fundamental counting principle and figure out the ridiculous number of slopes that I would have to find, and then go through and try and take an average of those to get a really good idea of what my slope should be. And then I'd have to go back and do the same thing with all the different possible combinations of points and average out all that. That's just not practical. Yes, that would be very accurate, but I need this to be simplistic too. And so they tell me that that's my problem, is trying to do both. So finding a linear model to represent the relationship described by our scatter plot is called fitting a line to data. And we're going to start off by doing this just by hand, using those 2 points with the understanding that it's not going to be an extremely accurate representation. So I could go through, take any 2 points, and find the slope. So y2 minus y1 over x2 minus x1 would give me my slope. And then I could choose one of those 2 points. I chose the 7, 120. So I could do y minus y1 is equal to m times x minus x1. And I could distribute that 8/5, which is down here, and I could add the 120 over and combine all of those like terms. But if I'm eventually just going to throw it in my calculator anyway, there's really not a need to do all that simplification. I could just move the 120 over so that I've solved for y equals, so that I could put that in my calculator. So I could see, okay, I've found a linear model, like they asked me to do in example 6, that relates the year with the number of people in the United States. Now, on the bottom of page A19, they talk to us about a correlation. And they show me 3 figures there on the bottom of page A19. What we're looking at here is a strong positive correlation. A correlation basically is just showing the relationship between the 2 pieces of information. Our information is pretty well clustered together. It's not like scattered all over the graph. It's pretty well clustered together, and it's going up. So that's what makes it positive. If it were going down, then it would be negative. And you can see that there on the bottom of page A19. You've got the first one there is a positive correlation. The second one is a negative correlation. Now, if you just have points pretty much scattered all over your graph and they don't really seem to be making any kind of a line or graph, or they're just kind of everywhere, then that we could say has no correlation at all. So if the points are really closely clustered together, we typically say they have a strong correlation. So like this would be a strong positive. If they're definitely forming a line and it's definitely going up, but they're not real tightly knit together, I might say that it's a weaker positive correlation, and we could do the same thing with a negative. And they also talk to you there on the bottom of page A19 about the correlation coefficient. That just represents a correlation coefficient is usually a number between -1 and +1, and closer that absolute value is to 1, the better the points could be described as being more like a line. So ours would probably have a correlation coefficient that would be a lot closer to a +1 than if the points were kind of spread out. So in any case, that's the terminology they give you on the bottom of A19. All right, so when we get to the homework, there are a few other things that they're going to ask us to do with this. We've kind of done all that we can do with this by hand, but we can use our graphing calculator to take this a step further. Even though we can only consider 2 points, my calculator can consider all those points, and it can give me a much better line that will fit all of that data, not just 2 points in that data. So grab your graphing calculator if you would. All right, to put information into your calculator, that's statistical information, you're going to go to statistics. So I'm going to go to statistics, and I'm going to choose edit. Now, all of these steps that I'm going to do are there in your notes, so that when you're looking back over this tonight, I've taken screenshots of every one of these steps so that you'll have something to guide you on the homework for tonight. It is a really good practice to get in the habit of, as soon as you start a problem, go up to the lists that you're going to use, like list 1 and list 2. Go up to those and clear them out. Because right now, all I can see is the information from 7 to 13. So maybe it ends up with, on my quiz or on my test, I type numbers on top of these, and then I forget there are numbers down below, and then all of my data is going to be wrong because there are all those extra points down there that I didn't want included that I forgot were down there. So it's just good practice to scroll up to list 1 and hit clear, enter. And when you do that, it will clear that whole list all at one time instead of you having to clear one thing at a time. Now, if by chance you hit delete, enter, it literally, sorry, if you're up there on list 1, and you hit delete, it literally is gone. Like, I go from list 6 to list 2. Like, I don't have a list 1 anymore. And if that happens in the middle of a test, you might have like a panic attack. It's a really simple thing to fix if you ever happen to do that. When you're in statistics, down here number 5, setup editor, if you hit that and just hit enter, when you go back to statistics, all of your lists will be back there again. Okay, so if by chance you don't want to hit delete, you want to hit clear, but if by chance you're ever missing any of your lists, that's a fast, easy way to get them back. So let's go through and let's put the information in from page A18. In our first list, we're going to put those t-values. So they went from 7 to 17. So literally I'm just going to do 7, enter, 8, enter, 9, enter, 10, enter. You get the idea. And then once you get 7 to 17 in your first list, I'll call out your second list for you so it's easier for you to follow along. So in your second list, you're going to put 120, 122, 124, 126, 126 again, 128, 129, 131, 132, 134, 136. Before you do anything on a homework problem or a quiz problem or a test problem, take the whole 15 seconds that it would take to go back and double check and make sure that you've got those ordered pairs in right, because if they're not right, every single answer is going to be wrong, right? Okay, so you should have 7 120, 8 122, 9 124, 10 126, 11 126, 12 128, 13 129, 14 131, 15 132, 16 134, 17 136. Okay? So that's how I can put the information in. Alright, once I've got it in list 1 and list 2, if I want to see that information, just like we put an equation in y equals and then we go graph it, I put this information in statistics. So if I want my calculator to plot those statistics, I'm going to go to a different place. I'm not going to go to y equals. I'm going to go right here above y equals to stat plot. So I'm going to go second y equals, and that's stat plot. I'm going to choose that first stat plot and turn it on. So just go to on and hit enter so that on is highlighted. Then come down, in this very first graph right here is a scatter plot. So I'm going to hit enter, and that'll give me my scatter plot. Now, right beside it, you can see if I wanted those points connected, or if I wanted to make a histogram, or down here if I wanted to make a box and whisker plot. So, you know, I have different options down here, but we've chosen that first one for scatter plot. Your calculator will by default use what's in list 1 and list 2. If you wanted to use something different, you'd have to tell it that. And then down here you can just choose, do you want it to put little blocks or a plus sign or a dot? What do you want it to use? I'm going to tell it to use the block. Now, I could easily go in and manually set my window, because think about how we did this on paper. On paper, we went from 7 to 17 counting by ones for x, and then we went from 120 to 136 counting by twos for y. I could tell it that. However, there is a handy-dandy button on my calculator under Zoom. We've talked before about Zoom number 4 and Zoom number 6 and Zoom number 5. Go down to Zoom number 9. Zoom number 9 is called Zoom Statistics, and it will take whatever information that you've put in those lists and it will set your window for you. So I'm going to choose Zoom number 9, and it makes a perfect graph for me every time. That's a happy thing. So it sets the window for me. If I went to window, you can see they basically did what we would have. They went through and said we were going from 7 to 17. They just gave you a margin of 1 on each side and counted by 1. On the y values, we were going from 120 to 136, so they just gave me a little bit of a margin on each side. They counted by 1 instead of 2. You know, same difference. So if we go back and we look at our graph, that's the exact same thing that we had on our piece of paper when we did it by hand. Now we've got it on our calculator, okay? So let's see how good of a job that we did with the equation that we created. I'm going to go to y equals, and I'm going to type in that equation that we created. So we had 8/5 times x minus 7 plus 120. Eight fifths x minus 7 plus 120. So once we've got our equation typed in, we can graph it. And hey, we didn't do too bad. We're definitely hitting the first point and the last point, because those are the 2 points we chose. And we even caught a point or two in between. So we didn't create a horrible mathematical model for the information we had. However, our calculator can make a better one because it can consider all of the points instead of just 2 of the points like we did. So let's look at how we could get our calculator to create that equation for us. I'm going to go back to statistics, and this is on the next page of your notes. I'm going to go back to statistics, and this time I'm going to go over to calculate. Go back to statistics and go over to calculate. Now, because our graph looked like a line, when I ask my calculator to fit a line to this data, I'm asking it to do something called a linear regression, and that's what you see in number 4. If this weren't a line, if this were graphing as a parabola, I would choose number 5, a quadratic regression. If it looked like that S-shaped cubic, I'd choose number 6. If it looked like a quartic I could just keep going. I have all kinds of options here, exponential, logarithmic, trigonometric, whatever I want. But because this one looked like a line, I'm going to choose number 4. I'm going to choose a linear regression, all right? So when I choose number 4, linear regression, and I hit enter, it tells me y equals ax plus b when a is 1.5 and b is 110. So what they're saying is put 1.5 in for a and put 110 in for b, and that would be the equation that would best fit this graph. So I could go back and I could plug that in. So I could go back. I'm going to turn this one off. I'll leave it in there, but I'm going to turn it off, and I'll come down here and I'll say 1.5x, because they told me to put 1.5 in for a, plus 110. My calculator will only graph what's highlighted, so since I only have that second equation highlighted, this is the equation that the calculator gave me. And so you can see that one's running a little more central than mine was. So mine was good. This one's just a little bit better. Now, the equation that we had right here was nice and neat and clean. You know, I had 1.5 and 110. A lot of times, though, when I do this regression, I'm going to get something that's got like 8 or 9 decimal places in it. And if I were doing something like a cubic, where it was going to find like A, B, C, and D, and each one of those had 9 decimal places in them, and I've got to go back and type those in by hand, the likelihood of me typing something in wrong or messing it up is higher. As smart as this calculator is, it ought to be able to auto-load that equation for me, right? It will. This is entirely optional. You don't have to do this. You can see we just had the calculator do the regression for us, give us the equation, we typed it in, we're good to go, okay? But optionally, if you want the calculator to automatically load that equation for you, you can have it do that. And the way that I would do that is when I had gone to statistics and I had gone over to calculate and asked it to do the linear regression, before I hit enter, I can tell it, do that linear regression, and when you're done, put that equation somewhere for me. And I can tell it where to put it, y1, y2, y3, y4, whatever, okay? If you remember, if you look up here, you can see in my y1, I have our old equation. So I'm going to tell it to put the equation in y1, and you'll see it'll go in and replace that, okay? So the way that I do that is if you have the new operating system, you're going to choose alpha F4 to get y1. If you don't have the new operating system, you're going to go to variables and go over to y variables and go to function, and there's your y1. Okay, so again, that is on your note sheet. It is entirely optional. You don't have to do that, but what this will do is it'll do the regression and it will auto load the equation. So right now in y1 I have 8/5 x minus 7 plus 120. When I hit enter, it not only calculates it, but if I go back to y equals, you'll notice that it has replaced what I had in y1 with that equation. Okay, so it will auto load it for me. So I'll clear this other guy out so that we just have one equation running. All right, why would I want to do this? I mean, why do I go through all of this trouble? Well, because they may have studied this data for 10 years, and maybe they didn't take the data in a year that I wanted. Like maybe I want to know what, based on this same kind of model, what the data would have looked like a year before, or maybe I want to know what it would look like 6 months in between, or maybe I want to know what it's going to look like 10 years later, because I have to do a projection. I'm doing an employment study, and I'm trying to build my city, and I want to make sure that, you know, I know 10 years from now how many people are going to be in the labor force, and I'm going out and recruiting jobs to make sure that they're not leaving my city, that they're staying here, that I've got work for them. There are all kinds of ramifications that we could have with this. And so they asked me, based on this model, how many workers would be in the labor force in 1986. All right, well, remember that we had said that t equals 7 represented 1987 all the way up through t equals 17 represented 1997. So if they said how many people were in the labor force in 1986, that would be like t equals 6. So I could either take the equation and literally just put 6 in the place of x, that would not be hard, or I could let my calculator do it for me. Remember that once I have something in y equals, I can do second trace to get to my calculate menu, and I've got that value button where I can tell it whatever the value is for x and it'll find the y value. So I'm just going to tell it, hey, I want x to be 6, and it'll tell me, okay, y is 119. It's the same thing I would have gotten if I had put 6 in the place of x. I would have gotten 1.5 times 6, which is 9, plus 110 would give me 119. So you can do it by hand, you can do it on the calculator. Then they said, predict how many would be in the labor force when t is equal to 30. All right, so I could go back then and I could say, okay, let's try that again. Let's do second trace value, and this time I'm going to give it an x value of 30 and ask it to give me the y value. The problem is it's going to give me an error message because it can only evaluate what it can see. And my window right now is not going up to an x value of 30. If you remember when we looked at it, our x value was only going up to like 18 or 19, something like that. It's not going to 30. So when I hit enter, it's going to give me an error message. So I'm just going to quit out of that. And if I go back to my graph, I have two choices. I could either go into window and just manually change it to go up to beyond 30, or I can fast and easy just zoom out, just like you would with a camera. If we go back to that zoom menu where we've used zoom 4, zoom 5, zoom 6, zoom 9, I'm going to go to zoom out, and when I hit enter the first time, nothing will happen because my calculator is giving me the opportunity to reposition my cursor. Wherever my cursor is going to be the center when I zoom out. So I actually have to hit enter another time before it zooms out. Now if I go back and ask it to find the value when x is equal to 30, now it can see it, and so it can find it. So let's review back through what we did today. All right, we went through, they gave us a list of information, we plotted those points by hand, and we saw that it looked like a line. And so we created a line to fit that information. We used the first point and the last point, and we got a pretty decent approximation for that graph. It wasn't perfect, but it was pretty good. And so we went to our calculator, and we had our calculator make that scatter plot. We went to statistics and went to edit. Remember, if you're missing any lists, how you can get them back. We went up to list 1 and hit clear enter, and up to list 2 and hit clear enter to clear out those lists, and then we went and typed those points in out of the textbook. Then we went to second y equals, which was our stat plot, and turned the plot on. We selected scatter plot for what's in list 1 and list 2, and we selected those little blocks. And we could have set the window by hand, or we could ask our calculator to do a zoom 9, which sets the window for us. And so we got a graph on our calculator that looked identical to the graph we had on our paper. All right, so then we went through and we took that equation that we had created by hand, and we put it into y equals, and we looked at it and said, you know, that's not so bad, but it probably could be better if I considered more than just 2 points. And so we had our calculator do that for us. We went back to statistics, and this time we went over to calculate and went down to number 4 since it looked like a line to do linear regression. And you can do linear regression enter, and it will shoot out that equation for you, and you can type that equation in by hand. Or you can get the calculator to auto-load that equation for you. That's entirely optional. With the new operating system, it's just alpha F4 to get to Y1. With the old operating system, we went to variables and then went over to Y variables to function and then down to Y1. If you do put that Y1 there using one of those two methods, not only will it do the regression for you, but it will auto-load that equation in Y1 for you. So whether you had the calculator loaded or you typed it in, then we had that graph that was a better fit. And then we could use that to go back and find information that they had not given me or use it as a predictor for upcoming information. So we started with saying, okay, in 1986, t was equal to 6. So we went to second trace, which is our calculate menu, and chose number 1 value and said, okay, when x is equal to 6, tell me the y value. So we hit enter, and it told us 119. Then it said how many would be in the workforce in 2010. So we said that's where t is equal to 30, and we tried putting that in, doing second trace calculate value, but the first time we did, we got an error message because 30 was off the screen and it can't evaluate what it can't see. So we went back and either changed the window by hand, or you can just hit zoom out. And remember, you actually have to hit zoom out twice before it does it, because the first time it gives you the option of recentering. So when I hit zoom out twice, it did zoom out, and then when I went back and asked it to plug in 30, it didn't have any trouble doing that. Okay? So we are doing one of these for homework tonight that will be identical to that process that we've gone through today. So for our homework on page A21, we're doing number 11, and it's going to be the same process as what we looked at today. When you get to B, we want to use the first point and the last point so that we're all using the same thing. And then again, just this reminder that I've already given you that you're going to need an add, subtract, multiply, divide, square root calculator for the first page of your test this week. No graphing or scientific.